Good afternoon, everyone. Thank you for coming. Let's start my presentation. I talk about the troubleshooting on-premise Kubernetes network, underlay, overlay, and pod. I'm Tomofumi Hayashi from RedHat. Today's agenda is the following. So the first time I'm introducing why Kubernetes network is difficult. And then it goes to the Kubernetes and its network setting up to troubleshooting the first step to introduce the Kubernetes. And then goes to the troubleshooting. In the troubleshooting section, I will go to the introduce how to identify the container interface, and then, of course, the IP table. And then the last thing is the packet capturing. As the packet capture, I'm showing the demo stuff. And then this QR code is about the slide URL. So if you capturing the stuff in the smartphone, you can see that. So if you feeling the Kubernetes network is easy, please raise your hand. If not, please raise your hand. Okay, comrade. I feel so too. So I'm thinking about why Kubernetes network is difficult. There is several massive stuff, but I'd like to sharing the three items. One is the many decisions at design and the coexisted multi-layered network, and then packet modification. The first thing is, once we are thinking about, hey, let's install the Kubernetes in my data center, my server, at that time, we need to consider a lot of things for design. I mean, the first time we need to setting up the host network, and then it goes to the container network. Nowadays, container network is the overlay, and then a non-overlay exists. We need to choose that IP address, network policy, and bandwidth if we need. And then, of course, when we're setting up the Kubernetes cluster, we can choose the load balancer service, or network policy, or ingress is the option. So if we thinking about we need to load balancer services, at that time we need to identify the commercial stuff or not, or open source, or is there any policy or stuff. So they're a little bit complicated at the design phases. And then, of course, the Kubernetes network is multi-layered network. I mean that not only the host network, as I mentioned before, container network exists. And then inside the container network, the packet is written everywhere. So for example, the software for the plan, for example, the open messages, if it exists, there's this rewriting the packet. IP table source at the host side is rewriting the packet by the Kubernetes component as well as the container network component. And then, of course, inside the pod, there is IP table rules. So this is very complicated. And then the Kubernetes network resource is also the IP tables and the IPBS services, the load balancer, and the bandwidth. There is lots of concerns. So when we're thinking about the one container host running the pod, at that time, when the process is the packeting to the Ethernet 0, and then after this stuff, the IP tables write something first, and then goes to the bridges. If this bridge is the open messages, maybe this rewrite the packet again, and after that, IP tables at the host side, we will do same things, rewriting the packet. So every time rewriting a packet, we do not identify the tracking, then they is very tough. That's another reason. So, and then the first step of the on-premise Kubernetes is install Kubernetes. So, and then of course, when I try to the Kubernetes, especially in the new container network stuff, at that time I'm goes into trouble. So I'd like to sharing how the Kubernetes and the network is setting up in each step of the kubeatom. So the simplified install is something like that. So the first time we install the operating system, CentOS or RHEL or stuff. Then we did the kubeatom init in the master and the kubeatom join at the node. And then after the finishing, we copying the CNI plugin and then of course the CNI config file. Then Kubernetes get into ready. At the first step, when we did the kubeatom init and the kubeatom join, at that time, in the kube control get node shows the not ready state. And then the pod, at that time, so the system component, like the kube API server, kube master, etcd is the running state. On the other side, core DNS is in the pending state. They are not all pod is in ready. But on the other side, IP table output shows the additional IP tables will be shown by the kube component. So at that time, the kube mark drop, masquerade, parse routing, adding the several rules. So summarize this stuff. The kubeatom, after the kubeatom init and join, at that time, the kube master register all nodes by the join, but this is not ready. And kubeatom also setting up the all pod, but the kube DNS or core DNS stuff is still in the pending. This is because the just waiting the container network readiness. And then the Kubernetes component also adding the initial IP tables rules. So at that time, we can verify that host network is okay, but the container network is not okay. I mean, they're not ready. We are still waiting. So once we copying the CNAP plugin and the config file as well, at that time, kube control get node result goes into the ready. Yeah, right. Then core DNS goes to the running, and then sometimes this case is the kernel case, but the new IP address rule is already also added. So this means after the CNF plugin and the config file copy into the node, everything, not only the host network, also the container network is ready. But of course, we can go to the failed case. And then I think that there is a two common failure case for the step 2. So I think the one is the CNI plugin and the config is failed. I mean, the CNI config file is the invalid. At that time, is one failure case. And the another stuff is the CNI config is valid. So the CNI programs successfully read these files. But this is not matched to our expectation or Kubernetes expectation. At that time, it's also failed. So I'd like to show how we identify which case is your case. So the both case, the kube control get node is same, ready, so that we could not identify which case is. So but we can see the pod, kube control get pod, and then in case of the case A, so if CNI configuration is invalid, at that time we can see in the container creating state in the kube pod, and then also the failed create pod sandbox reason in the describe. This means once the CNI plugin and the configuration file is copied into node, Kubernetes, actually the kubelet is trying to create the pod. Then they're trying to invoking the CNI plugin with the configuration file. And then if configuration file is invalid, or you only copying the config file but not the CNI plugin, at that time, this is explicitly the failure case. So kubelet does not launching the pod. So that's why we see the failed to create pod sandbox state. But on the other side, if CNI configuration is the valid case, at that time, of course, kubelet successfully launched the pod. But then that's why the kubedns is showing the running state. But the kube control described the pod shows warning unhealthy state. This is because the readiness proof failure case. So some pod have the readiness proof in the pod YAML file. Readiness proof means they're sending the REST API to somewhere to validate the network status, and of course the container health check. So if you write the wrong CNI network configuration, at that time, maybe we can create the pod, but this network is not to go outside, or maybe the Kubernetes server or something like that. So at that time, maybe we goes to the these unhealthy readiness proof. Then even though this is the running. So that's the, so we can identify the two cases in case of the copying CNI, and then maybe this can be helpful to identify the first step to introducing the Kubernetes. Then goes to the troubleshooting. The troubleshooting is the very wide topic, and then of course I could not introduce everything in the 30 minutes, or maybe more than 1 day, or I don't know. And then of course I don't know everything about the Kubernetes in the future as well. So I'd like to introducing the how to identify the container interface and the IP packets, IP tables, and the packet capture, very simple stuff. So the Linux network, as the first step is the troubleshooting, is IP address show commands. We can check the IP address and then its link status and this stuff. But how about in the container? Especially we can see the CNI0 interface, but I don't know which types of the interface is the CNI0. So the first step is IP command with D option shows the interface type. So this D option location is important. So just after the IP commands, IP -D, the address. Or maybe, of course, the other commands of the IP also supporting the -D option. So the IPD link show. At that time, with the -D option, we can see the bridge keywords. There is not existing without -D. With the option, we can see this interface type. So at that time, the CNI0 shows the bridge. So this is the Linux bridge. So in case of the container, we frequently seeing these line, the BETH. So this means the BETH means the virtual Ethernet device, which is the point-to-point virtual connection which the Linux kernel provides. But after the aftermark, it's every time I'm thinking of what IF3 means, so I'm investigating about that. Let's close up the output. Then here is a mapping. So let's introduce each step. The first step is this number. This number is the IF index. This is the interface identifier of this namespace of a Linux kernel. And then goes to the next is the interface name, just the name. Okay. The IF3 means this is the opposite side interface index of the virtual Ethernet. So this BTH7F 8A stuff goes to IF3 index, the interface. So from these informations, so the left side, the DNS is the IF index 6 and the BETH, and with the IF3, and then there in another namespace, or maybe sometimes in the same namespace, we can have the IF index 3, and then end with @mark IF6. Then, so I try to find this stuff, and then, yep, I can find that. So we can checking the @mark stuff, and then of course the left side number. We can see which interface goes to which namespace. And then, but so there is another question. In case of the container, like the Nginx or simple small type cleanup container, we don't have the IP command, right? So IP command is not so handy. And then of course some container introducing the full version of the IP commands. At that time, the -D is not exist. How to do that? Linux have the NS enter commands. which do with the -t and the -n option, we can using the host side program at the container. So the commands execution is in the kube node 1, and then this output is this PID comes from the NGX container, and then I add the IP-D address share commands in here. So between the -n and the IP, we add the /2 mark, and then we can see this output. At that time, this IP command comes from host side, not the container side. And then this NSEnter requires the sudo command, so you need to have the root privileges as well. But using this stuff, even though the container is simple and then they don't have the IP commands, we can invoking IP commands from the container side. And then next is the how we identify the PID. That's the also problem. Maybe sometimes that we can just the PS command to identify in some cases, but if let's imagine that the various Nginx container is running at the same host, of course it's very hard, you know. So that's the way to identify the interface. The first time, let's do the kube control get path with JSON or YAML. At that time, we can see the container ID in its output. Container ID may be the something like the Docker // something long figure, or maybe the CLI-O / in case of the cryo case, this stuff. And then using this figure in the target kube node with the Docker inspect for Docker runtime, or cry control inspect, and the stuff for cry runtime, we can get the PID from this output. That's the one to identify the PID of the pod. And then we do NSEnter like that. We can get the interface output. And then IP tables is, as I mentioned before, IP tables is not only inside the container host, also the IP tables is in the pod. So the first thing is who adds the IP tables? That's the maybe the first step to we are thinking about. Almost everything. Like, you know, so kubelet adds the kube post routing, kube merc masquerade, kube merc drop firewall, and the kube proxy, kube post routing forward. The chain exists, and each chain have the several rules. And then CNI also adding the several rules, and the weeb, like the weeb adds the weeb and the weeb MPC network policy controller stuff for each chain. And then if you're using the HCO, it's also adding the several chains. So at that time, maybe the 20 or something. And then, of course, if you're using the another stuff, another component also adding the IP tables. It's good for container networking from a user perspective, but it's very hard to network administrator or Kubernetes administrator. So I'd like to see some of the hint to debugging this stuff is especially in the kube proxy and the kubelet. So they create the hierarchical structure in the IP tables chain. So in case of the NAT, pre-routing or output chain, they created on top of this stuff in the kube services in top of that. And then this chain is to connect to the kube SBC services items for each services. And then kubesep stuff is continued to that. And then kubesep adds in the kube mark masquerade stuff. And then this goes to the right-hand side, the post routing. And then some cases they changing the destination as a NAT. And then in NAT case, this is the two chain to just adding the kube post routing and then goes to the masquerade. This is very simplified than the pre-routing output. And then On the other side, the filter input, filter forward, filter output, there is the flat case, so it's easy. But so the pre-routing output is a little bit challenging. So it's pretty care about that. And then regarding the IP table stuff, the last KubeCon at the EU, the Google Minhan and Rohit does great talk about the IP tables. So black holes and the wormholes, understand it, troubleshoot in the magic. Yeah, they think the magic. Okay, good. And of Kubernetes networking. So that if you are checking this stuff, and then they introducing these IP table stuff mainly. So I recommend if you're interested in the packet capture. So usually in the troubleshooting, the fundamental stuff is the capturing the packet. Capturing contains lots of information. So where we can we capture the packet? Looking at this stuff, there is three stuff. One is the container host Ethernet 0, and then the bridges and Ether0 of the pod. But regarding the pod side, how do we capture without a Wireshark in the container? So yeah, of course, I understood the various container images does not including the Wireshark, and of course, we could not ask the Kubernetes users, hey, let's use this container for the production. It contains Wireshark. it's funny. So how to do that? And then also I'm wondering, and then I'm creating some tools to the Kubernetes pod network tapping. This called the CocoTap. CocoTap taking the argument of this stuff. One is the pod name, and then next is the VXLAN ID, and the destination node, and the mirror type. I will explain these next slides. So let's imagine the following environment. I mean the KubeMaster and the Kube Node 1. And then KubeMaster install the Wireshark. At that time, we'd like to trying the capturing this Ethernet 0 packet, not after rewriting the packet by the other stuff. When we invoke executing the CocoTap command, hyphen the pod name, VXLAN ID, and the destination node and the mirror type, then CocoTap creating the mirror interface at the Kube Node 1, and then this also using the Linux TC mirrored functionality. Ethernet packet is mirrored by this interface. And then this interface is the VXLAN interface, so that this goes to the Underlay network with the VXLAN encapsulation. And then this CocoTap is also create the VXLAN in the KubeMaster side. So once after creating this stuff, we just capturing the packet at the KubeMaster, and we can capturing the packet. And the mirror type is showing the which direction we capturing of the Ether0. If we choose the ingress, at that time, only the from outside to the pod traffic is captured to this mirror interface, and the egress is outside. So we only capturing the from pod to outside. Both is just the ingress plus egress. Okay, let's the demo. This is live demo, so let's see, kube control get node first. There is the 2 node and 1 master. Yep, that stuff. So there is the, inside my laptop, I'm launching the 3 virtual machine, kube master and the node and the kube node 2, and then there is the Ethernet devices. And then this is also connecting the virtual BR devices at the host. Let's go back here. Kube control get pod. I'm running the Nginx here. So, and then IP show, IP address show there. So currently there is no mirror interface yet. Okay, let's create the mirror interface. So the CocoTAP taking the argument pod NGX, VXLAND, and the destination node is the kubemaster. So this command creates the YAML file. So we need to add the pipe to add the kube control to this input. Then this creates the CocoTAP pod. Then this is already running state. And then after this stuff, IP address show commands seeing mirror interface in here. And then, of course, we do -d option. At that time, we can see the VXLAN interface, and the VXLAN ID is similar. And then let's go to the node side. This is the port NGX is running. So use and MS center T. So with the NS Center commands, we can see not only the Ether0 devices, also the mirror interface is newly added. Okay, let's capturing the Wireshark. Kube control get port or wide to seeing the IP address, and then let's see NGX. Then we can capturing the HTTP output at the kubemaster. Of course, this again we can see that. So that's the first step. Then to removing this interface, just the delete. Then the both interface, mirror interface at the kubemaster, and then the mirror interface and the port is removed. IP, D, link, show. Oh, maybe we don't have the D. Okay. There is no mirror interface as well as NGX side. That's the first step. And then sometimes we also would like not to install the Wireshark in the kubemaster, right? So at that time, I also have the way to do that is dest. So instead of the destination node, we could add some certain IP address for destination IP to create the mirror interface. So let's try that. Then get port. So at that time, the CocoTAP only creates the mirror interface at the port side because the opposite side is unknown for Kubernetes. But so this time, this IP address is this virtual bridge stuff. So so I need to create the VXLAN interface by hand for now. Then Wireshark, let's do the Wireshark. Then of course here is the VXLAN 0 interface here. Then starting the capture. Then also in the CocoTAP commands, I also choose the ingress as a mirror type. That's the stuff. Let's get the crawl. At that time, no. At that time, okay, let's filter the HTTP for easy to debug. At that time, we can only see the get command. There is no output. This is because I choosing the mirror type in the ingress. So if we choosing the egress at this stuff, then we could not see the get command. Instead of the get command, we can see the output of the HTTP. That's the demo. Then go back to slides. Yep, literally that's about it. So in this presentation, I'm showing that the Kubernetes network is the difficult. The reason is the 3 stuff. And then goes to the Kubernetes and network setup to identifying the first step to troubleshooting. And then in the troubleshooting section, I will introduce the how to identify container interface, I mean the -d option after the IP, and the IP tables a little bit, and then packet capture as a demo. That's about it. So I'm showing the QR code of my presentation again, so that please look into it if you're interested. And then CocoTap is already in the GitHub, so please use it if you're interested in. That's about it. Thank you for your attending.